Ever wondered why a giant ship floats easily, but a small pebble sinks? Or why you feel lighter when swimming? Today, we'll unlock the mystery of Archimedes' principle. You'll learn about buoyant force, fluid displacement, and how they connect. First, we'll define buoyant force, then explore displacement. Finally, we'll reveal Archimedes' brilliant discovery. Imagine an invisible hand pushing you up in water. That's the buoyant force. It's an upward push from a fluid, working against an object's weight. This force makes things feel lighter, or even float. When an object enters a fluid, it needs to make space. It pushes some of that fluid out of the way. This is displaced fluid. Crucially, the volume of this displaced fluid equals the volume of the submerged object. Think of it, the water moves aside to make room for what's immersed. Here's Archimedes' brilliant insight. The buoyant force on a submerged object equals the asterisk weight of the fluid it displaces. Let's look at the math. F_b equals rho vg. F_b is the buoyant force. Rho is the fluid's density. V is the volume of displaced fluid. And g is gravity. It's like a trade. To float, an object must displace its own weight in fluid. Giant steel ships float because their shape displaces immense water. This creates a buoyant force greater than their own weight. Submarines dive and surface by changing their density. They take in or expel water from ballast tanks. Now, for you, why does a hot air balloon float? Hint: think about the density difference between hot and cool air. Buoyant force is that upward push from a fluid. Fluid displacement is an object moving fluid aside to make room. Archimedes' principle ties them together perfectly. The buoyant force precisely equals the weight of the fluid displaced. This explains why ships sail and toys float. It's a fundamental physics concept, all around us. Keep exploring with that curious mind.